Today the topic for discussion is graphical representation of linear motion. Okay, before we start with this topic, I will briefly like to understand from you or know from you. Do you have any can you explain me what are the different types of motion which we have studied in this chapter? Uh, Motions can be of different nature. Like for example, if you see a granddad or granduncle walking in a park, he maintains the same speed and moves continuously with the same speed. Like with a stick in his hand, is walking around the park with the same speed. Such kind of motion is known as
So uniform motion.
uniform motion. So, can you describe uniform motion?
He like for example the granddad he'll move with equal speed for equal distances.
Okay, so in fact,
Yeah, with the same speed.
so he travels equal distance in equal interval of time. Unlike a young boy, maybe like young boys or young kids, or when they are moving around, they sometimes move fast, sometimes move slow, based on like how the path is. Like okay, so if the road is empty, they will try to run. So just an example, what I'm trying to say, motions can be of different nature. One is when the speed does not change, means the object is moving at the same speed. Like for example, you're driving a car and the car is in the cruise control mode and it is fixed to 80 kilometer per hour. So in that case, you see that the speed does not change. It just maintains a 80 kilometer per hour speed during that journey. But there can be other kinds of motion as well where the speed changes. For example, if I talk about an object which is falling down towards the surface of earth, means if I go to a 10th floor in an apartment building and drop a cricket ball down, what is the nature of the motion of the cricket ball? Is it moving with the same speed or the speed changes as it is coming down?
So same speed, I think.
So the the speed at which the ball gets released and the speed at which you catches it is same to same. Okay, let's take bring others in. Parishi, what is your opinion on this? When we drop a cricket ball from, let's say, third, fourth, or fourth floor in an apartment building, okay, does it continue to move at the same speed during its entire journey, or the speed changes?
So I think it'll change.
It changes. It
Like it'll
increase.
increase.
It increases. Okay,
Yeah.
Sneha, what is your opinion on this?
So it depends on the person, like how fast he's throwing the ball.
No, he's
I
just
think it
releasing it.
changes.
He's just
I
releasing.
think it changes. It cannot stay same according to me. I think it changes.
Okay, what floor do you stay on, Sneha?
So 13th.
13th floor. Okay, suppose if you drop a ball, cricket ball, okay,
Okay.
from 13th floor to the ground floor,
Okay.
and another person drops it from the 25th floor to the ground floor.
Okay.
In which of the two situations it's most likely that the person who's trying to catch it will get hurt more?
The 25th floor one.
And why is it so?
Yeah, no, probably. I mean, I think mine because like less height. I think it's mine. 13th floor. Because while coming from 25th floor, I think it slows down till then.
And what is slowing it down?
I guess gravity or something. I'm not sure.
Gravity is pulling it down. Okay,
So stop, sir. I think 25th floor. I don't know. I'm not sure at all.
okay, no problem. See, the thing is, this is what we need to understand here in this chapter. See, whenever a body is moving under the influence of gravity, like it's moving down, in the influence of gravity means you have just released it from some height and it moves towards Earth. In that case, speed does not remain same. It is an example of an accelerated motion. Okay, so if a body is coming down from some higher altitude, from a higher floor to a lower floor to a ground floor, let's say, in during the journey, the speed continuously changes. Like maybe here, see, when you simply release a ball from a height, at that time there is no speed. So speed is 0 meter per second. If you simply release, you're not pushing it down. There's a difference between pushing it down and just releasing it. So if you simply release it from the 13th floor, speed initially is 0 meter per second. But as it comes down, the speed increases to 10 meter per second, 20 meter per second, 30 meter per second. And such motion is called as accelerated motion when the speed changes. Am I clear? Okay. This is unlike suppose there is a cycle person, like a person driving a cycle, a bicycle. So initially, when he starts from rest, his speed initially is 0 meter per second. For some time, he pedals hard and try to achieve a speed of, let's say, 20 meter per second. During this time, again, the speed is undergoing some kind of change, like there's increase in speed. So again, we can say during this part of the journey, the body is accelerated. But later, let's say after this point, if body maintains the same 20 meter per second ka speed for some time, for next 20-30 minutes. So in that second part of the journey, when the speed is not changing, we say body is moving with a uniform speed, or it is a uniform motion. So the two type of motion which mainly we are going to study in this chapter is, or which you need to have a clear understanding of, is first uniform motion. Okay, so uniform motion is where the speed does not change. It continues to move, like the object continues to move at the same speed. Can you really differentiate? When I say feel, can you really differentiate between two objects when it is in uniform motion and it is not in uniform motion? Right? If a car is moving with some on a highway towards an airport, and in that speedometer in the car, it's a digital speedometer, let's say, and it is writing 80 kilometer per hour, and it does not change. If you have ever had experience of traveling, obviously you must have had an experience of traveling in an airport cab, but I don't know how carefully you were observing the meter, that the distance display. Sometime you will find that the speed actually clocks around 80 kilometer per hour on the highway, and it stops. It doesn't go more than that. Okay, it stops. And in some vehicle it stops at 100 kilometer per hour. You know why that happens is because maybe like for the airport cabs, the company which is running the cab has like kind of fixed it, has somehow tried to control the higher speed, so the driver can't go faster than that, so that is for the safety purpose. So in that situation, if you see the speedometer of the car, it will say 80 kilometer per hour. It is fixed. It means it's not becoming like, it's not the speed is not increasing or decreasing at that moment. It's moving at a fixed rate, right? So it is covering equal distance and equal interval of time. That is what uniform motion means. Correct? Okay. And an accelerated motion, on the contrary, is where the speed increases. One example I told you for accelerated motion is when you drop an object. So whenever we drop an object towards earth, the body continues to move with the increasing speed. The speed does not remain same here. Okay, that's why if you drop an object from a higher altitude, okay, maybe from the 24th floor instead of 13th floor, the speed of the object when it reaches the ground force is much higher, because it has traveled all the way from 23rd floor. Okay, and then the chances of getting hurt is more when it travels all the way from 23rd floor, because in the longer journey the speed increases by a greater amount. Am I clear? Here on the paper you see a displacement time graph. On the y-axis I have written displacement. Y means the vertical axis, I have written displacement, and on the horizontal axis I have written time. Okay, and it is demonstrating a kind of a motion. So displacement time graph is used to represent motion of object. Now the immediate question comes, so what is displacement? Okay, displacement basically means the position of object with respect to an observer, the change in position of an object with respect to an observer. So imagine that this is some point where observer is standing. This is observer point, okay, and like this is where the object is. Let's say at a distance of 5 meter from the observer. Okay, and this is when in the beginning of, like when time is zero, object is at 5 meter from the observer. So I can say the displacement of the object, this object, with respect to the observer is 5 meter right now. Okay, so how do we represent that on the graph? Like here, maybe this is 5 meter length, this point is 5 meter, and this means time is zero. Okay, this is t is equals to zero. So at time t is equals to zero, what's the displacement? 5 meter, right? Now as you move towards the right side, time increases. Like this is time 1 second, 2 seconds, 3 second, 4 second. Okay, look at the graph. What happens to graph? Displacement value, is it changing? Displacement value, can you tell me at 1 second what's the displacement? At 1 second, like from the graph, what is the displacement? Okay, let me repeat my question. See what happens here. Here you see there is a displacement time graph. I'm trying to help you understand how to read a displacement time graph. That's my objective. So at this point, time is zero. And as you go towards right side on the graph paper, Okay, towards the x-axis. Time increases from 0 to 1 second, 2 second, 3 second. Okay, at 0 second, see this blue graph is the actual displacement time graph. The black lines are actually just the axis. So when I see at 0 second, what is the displacement? It is s naught. Okay, let's give that s naught a value. Let's say that is 5 meter. So what is displacement as at 0 second? 5 meter. Similarly, what is displacement at 1 second? Again 5 meter. Displacement at 2 second? Again 5 meter. And displacement at 3 second is again 5 meter. So my question to you is displacement changing with respect to time? Is displacement changing with respect to time? No, right? It's not changing, right? It's not changing, it's same. Okay, and in the beginning of this discussion, I told you what is displacement? Displacement means with respect to an observer, what is its position? Okay, so the object position at 0 second is 5 meter. At 1 second also it is only 5 meter. At 2 second also it's 5 meter. 3 second also it's 5 meter, means it's 5 meter from this point. Like from this point it's 5 meter. So is displacement changing in this case? No, right? And if displacement is not changing with respect to an observer, is object moving? What do you think? Is this object moving? It's not moving. Okay. So this is what I want you to understand. The graph which I've drawn you is a graph for the case when object is not moving. It is stationary. Okay. In that case, the displacement time graph is a straight line. So if displacement time graph is a straight line, okay, as you see here, displacement time graph is a straight line parallel to time axis. Okay, it's parallel to time axis. It means displacement does not increase. That means the object stays where it is, and with respect to an observer, the displacement does not change with time. This is representation of body at rest. Why is it important to even understand graph for or the displacement time graph for a motion? Because there are a couple of information which we can derive from the graph, because it actually makes our understanding of motion more simple. So the one information which we generally get from the displacement time graph is slope. Slope of displacement time graph gives velocity of the body. So we will see this through some question and answer later as we proceed. Just for now, you remember, slope of a displacement time graph gives velocity of the body. So if you find slope, you can find the velocity. Means finding slope is like finding velocity of the body. Clear? Let's move ahead. Briefly, what do you mean by slope? Suppose the graph is moving upward direction. Okay, here the displacement time graph. Can you see with respect to time, displacement is increasing here? Okay, same even in this case, this displacement is increasing. These are representation of positive slope. So if the slope is positive, the body is moving away from the point where it started. Okay, now see, in this graph paper, what they have done, they're using the x-axis to represent time, and they're using the y-axis to represent the displacement of the object. Means how much is going forward, backward, like that. What is time for this point?
So 0
And what is displacement for that point?
for 0.
0 comma 0. Okay, suppose there's another point here. If I ask you what is time for this point, what time it represent this point?
8,
So 8.
8. And what is displacement of this point?
4.
4.
4. Now if you understood this, okay, let me try to demonstrate a motion with a straight line. Okay, now this line here is representing a displacement time graph of an object which is moving. So if I ask you based on this graph, okay, can you tell me when the time is 2 seconds? Okay, displacement is given in meter. When the time is 2 seconds, what is displacement of the object?
Is
This
it
point.
4?
So 1.
1. It's 1 because it's between 0 and 2. Can you see it's 2 here? So when it's 2, it's 1 over here. So what is this line representing? It is representing motion of a vehicle which is moving in a straight line. And this line is telling you that at different points of time, what is the displacement? For example, if I ask you, like when time is 6 seconds, what is displacement of the object?
3.
It's 3 meter, right? But see, one thing which I want you to understand, you should not get confused with this graph that the object is actually moving in this in this direction. That's not what this is trying to tell. This is just trying to tell you that there is one object, maybe a car, which is undergoing displacement. This is the starting point for me, and this is like a straight path. So car is just moving along this straight path. At time t is equals to 0, there is no displacement, means the car is at the starting point. Okay. At time t is equals to 2 second, after 2 second, car covers 1 meter distance. Okay, it covers 1 meter. So the car is here. Like maybe from here to here, the distance is 1 meter. At similarly, time t is equals to 6 second, car is at a 3 meter distance. Like from the starting, it is 3 meter distance. Okay, so the car is here. So you understood what's happening here? Like what is displacement time? What kind of information the displacement time graph is trying to convey? Okay, now look here and just tell me, in the beginning when time is 0, what's the displacement from the graph? What can you say?
So 0.
0, that's all. So in the starting, there was no displacement. That's what the graph is trying to tell you. Okay, now Sneha, just look at the graph and just logically, okay, no rules, no formulas, nothing. So my next question to you is, as time is increasing, from the displacement time graph, what can you tell about the displacement? Is it increasing or decreasing?
Increasing.
This is 1, 2 second, 3 second. Okay, this is displacement at 1 second. This is displacement at 2 second. Okay, I've not done labeling here, but just logically, can you tell me, like at 1 second we have more displacement, or at 2 second we have more displacement? Where is displacement more, at 1 second or at 2 second?
So 2 second.
Certainly 2 second, the displacement is more than the 1 second. As time is increasing, displacement is increasing here because the line is going up. So that is what we mean by positive slope. Okay, see above it's written, if the slope is positive, what do I mean by slope is positive? Means the line is going up like this. So whenever line is going up like this, displacement increases. Displacement increases means the object which you are talking about, no, it's going far away from its original position. Clear? Okay, since both the graphs are same, I'll just erase the second one. That's not even required. Suppose there's another object. In this case, like displacement time graph is like this. The displacement is decreasing with time. Okay. At 0 second, the body already had some displacement, maybe 5 meters. So it already had some displacement. And then as time is increasing, at 1 second, displacement is less. Can you see? At 2 second, the displacement is even lesser. Okay. So I want you to understand the difference between these two graphs. See, first graph, with time, the displacement is increasing. So in this situation, you can think about a car, okay, which is at rest. And as time is increasing, it's going far away. So at 1 second, the displacement is some 5 meter. Okay, this is 1 second. Then after 2 second, displacement is, let's say, 10 meters and so on. Clear? While the second graph here, displacement is decreasing. That means the car is already far away from the observer. Like this is where the observer is let's say this is observer. So car is already far away from the observer, but like this is time is equals to 0. So at time t is equals to 0, car is already far away. But as time is increasing, the car is coming closer. So at t is equals to 1, displacement is less. Okay, at t is equals to 2 second, it's even less. Okay, I hope I am able to clearly convey what I intend to say. Is this clear? Do you understand difference between the two graph, all of you? When the graph is going up, it means the car displacement is increasing with time, means car is going far away. And when the graph is coming down, it means displacement is decreasing with time, means with time the car is coming closer. From the displacement time graph, answer the following question. The kind of motion depicted in a graph is, what kind of motion is it? Is it a uniform motion? Is it a non-uniform motion? Is it a retarded motion? Or is it all of the above? Look at the graph and try to help me understand. What is your opinion on this? What kind of motion is being depicted by the displacement time graph?
So uniform motion.
And now can you try to explain
So
me why is it so? It is certainly not a non-uniform motion.
so so speed is increasing with equal interval.
There is no information on speed. Where do you see speed written, first of all?
I mean, sorry, sir. The
The
displacement.
displacement increases with time. Okay. So from at 0 second, what was the displacement at 0 second?
So zero,
Zero. And what was the displacement at 1 second?
20.
So let's say the car is getting displaced. Okay, or this object is getting displaced. At t is equals to 0 second. Okay, this is at zero, means it is at the starting point. When I say zero, no, it means it is at the starting point. At t is equal to 1, where is it? 20, means 20 meter from the starting. It is 20 meter from the starting. At t is equals to 2, what is the displacement?
30.
So 30.
I think here there is a mistake then. All right, I think this is a mistake. This should be continuous, because 0 it's going to 20 straight away, then 30, 40, 50, 60. Okay. Let me just make this a little correction over here. Otherwise, okay, let's make this 10 then. At 0, this is not at the starting. At 0, it is at 10 mark. Okay, like 10 meter from the starting. It's already 10 meter from the starting at 0. Okay, so at 0, the displacement is 10. Let's say at 0 second, it is at 10 meter. Means, see, this is the starting point. When time is 0, no, the object was here, 10 meter from the starting. At 1 second, this is how much? 20 meter from the starting. At 2 second, it is 30 meter from the starting. Okay. So the point is, between 0 and 1 second, how much it moves forward? What is the displacement in 0 to 1 second? It moves forward by how much?
So 10 meters.
10 meter. And then from 1 to 2 second, how much it moves further by?
So it's the same throughout 10 meters.
Okay. So you see that whenever you move by 1 second, like 1 to 2 second, displacement increases by 20 to 30, by 10. When you go from 22 to 3, 1 second, okay, it again further travels 10 more meter. When we like when the time increases by 1 more second, displacement again increases by 10 second. So it means that every second the car is traveling 10 meter extra. This is what uniform motion means. Okay, what is the velocity between A to C? So A to C, what's the displacement?
So 60 meters.
3 or 30? At A the displacement is 30, at C it is 60. So between A and C, what's the total displacement? 30 meters. And A to C, what's the time elapsed? 2 to 5, 3 seconds. And we know from the last part that speed is equals to, or velocity is equals to, displacement by time. So the displacement here is changing by 30. So 30 divided by time 3 seconds. So
So
that
it's
is
10 meter per second.
10 meter per second. Yes. You have to just look at A, what is the position? The car is at 30, okay? At C, it is at 60. So A to C, it goes how much forward? 30 meter. In how much time? 3 seconds. What is displacement at t is equals to 3 seconds? Right at 3 seconds, what's the displacement? That you can directly tell from the graph. When time is 3 seconds, at that time, what was the displacement?
40.
3 seconds, it is 40, right? That's all. Clear? I hope all of you understood this, right? No problem. Let's move on to the next question. Out of the following, the correct displacement time graph for uniform motion is. So look at the four graph. Tell me which one is representing uniform motion.
So B.
B is
So
representing.
B.
P.
Okay, so this is like the previous one, right? Okay.
Yes, sir.
A is representing what kind of motion? This is the first thing we discussed in today's class. I'm giving you a hint.
Ununiform.
Okay, I'll give you more hint. If you observe the graph carefully, as time is increasing, displacement does not change. Time increases, but the displacement does not. Displacement increases when the graph goes up or down. Here, the displacement does not change. Does not change. Let's say this is an observer point. Okay, observer means anyone can be an observer who is still, who is stationary. Okay, so maybe a building is an observer, or a person standing at one point is an observer. Okay, now this object is like at t is equals to 0 means when I started noticing t is equals to 0, when I started observing, I found that this object b is at 5 meter with respect to the observer. Okay, then I saw after 1 second, I found that the object is still at 5 meter with respect to the observer. Okay, at 0 it was 5, at 1 second also it's 5, displacement is 5 only. At 2 second also that object was at 5 meter only. Okay, so what is the nature of B's motion? Is it moving?
No, sir.
If it moves, the displacement will change. You're getting my point there. So this first graph is basically just an object which is at rest. Okay, and the second graph is uniform motion. I hope that's fine. Here on the same displacement time graph, we have represented motion of two objects A and B. Okay, tell me which of the two object is moving faster, which has more velocity. Let's put some numbers. Okay, by ourselves, like this is, let's say, 5 seconds, and this is okay, let's say 12 seconds. Okay, for B the maximum displacement, let's give some value, let's say 100, and for A let's say it's more, right? So I'm just randomly giving a value, just trying to keep it more. Okay, so can you tell me for B what is the total displacement from 0 to 12 second? In 0 to 12 second,
100.
it's 100 displacement, right? The displacement is 100. In how much time?
12 seconds.
In 12 seconds. 100 meter in 12 seconds. This is B. While for A, it is traveling 200 meters. And in how much time?
5 seconds.
No, 5 to 12. This is 12. So it is traveling 200 in 5 to 12 is how much? This much time, right? It started only at 5 meter. Before that, it was not moving because the displacement increases after 5 second. Means before 5 second, it was not moving. It started moving after 5 second. And in 5 to 12, like in 7 second, it travels 200 meter. Clear? Simple. Are you getting comfortable with the graph?
Yes, sir.
Now, of the two, which is bigger? Which is faster? 200 meter, more distance in less time. Obviously, it's faster, sir. More distance, less time, isn't it? That is what faster bodies do. They travel more in less time. That's why we call them faster. Okay, so this is faster. Okay, now see there, here we have some displacement time graph for you. This is B, this is C, and this is D. So among these four graphs, can you tell which one, okay, which one has a zero acceleration, positive acceleration, or negative acceleration? Okay, so from displacement time graph, we have to tell acceleration. I think let's go one by one. The first graph here. What do you mean by first graph? Forget the acceleration now. Can you tell me what do you understand from this graph about the motion of the object? How is it moving?
So I think it's retardation.
No. S is displacement. Displacement is decreasing with time. So displacement is decreasing with time means the object is
So slowing down,
no.
I think.
It's coming closer. Okay. In the first picture here, if you see the object is like as time is increasing, displacement is decreasing. It means the object is coming closer. But see, if you look logically, since the graph is a straight line, okay, if in 1 second it decreases by some amount, next second also it will decrease by same amount, and the next second also it decreases by same amount. So the object is coming closer, but it is coming closer at uniform speed. So this is not accelerated, and therefore here acceleration is zero. Okay, so what I want to tell you here is, if the speed does not change, whether the object is going far away or is coming close, like it's uniform motion, right? So either if it is moving uniformly, speed does not change, then that is an example of accelerated motion. Sorry, non-accelerated motion. Acceleration is zero. Clear? Okay, so this is again time axis and this is displacement axis. So when time is 2 seconds, what is the displacement? 2 meters. So in 0 to 2, the displacement in 2 seconds, the displacement increased by 2. In another 2, it increases by another 2. So in this case, you see, in every second, the displacement increases by the same amount. Means here 2 seconds, displacement is 2 seconds. See, I'm not saying that this is 2 seconds, so this also needs to be 2 meters. But when the graph is a straight line, in equal interval of time, there will be equal increase in the displacement. So 2 second, displacement will increase by 2 meters only. Okay, like 2 seconds, it will increase by the same amount when the graph is a straight line. Clear? But if suppose the graph is not a straight line and it's like this, it's a parabola graph like this. Okay, in 2 seconds, what is the displacement? I think roughly half meter. In another 2 seconds, how much is displacement? It goes till here. So it's 1.5. So it increases by 1. Then 4 to 6 seconds. Okay, in 4 to 6 seconds, if you see, it increases by this much. Okay, so if I just darken it, like see, 0 to 2 seconds, it's increasing by this much. In 2 to 4 seconds, it's increasing by this much. In okay, 6 to 8, it is increasing by this much, and then it's further increasing by this much. So can you see the displacement is not uniform? Like initially it's going less, and then as the time proceeds in the consecutive seconds, it is going more and more. Okay. See the first one, the body is coming back, but it is like the displacement time graph is a straight line, either coming back or going away. In both these cases, the object travels equal distance in equal time. So first graph here means, okay, the object is coming back or it's moving towards the or is a starting point. Okay, starting point. But here acceleration is zero. The second last one also acceleration is 0, but it is moving away from the positive point. Okay, it's moving away from the starting point. Okay, but in these two cases, like the middle one, B and C, in the first case, you see that in consecutive interval of time, the displacement increases. So it means the object is becoming faster and faster. So here acceleration is positive. While in this case, if you see in the first second, it travels more distance. Okay, if you try to break it into equal interval of time. See, first this second, it travels this much distance, more distance. Second, it travels a little lesser. And in the third second, it travels even less. So what I understand from this graph is the object is slowing down. So here acceleration is negative. It's slowing down, means acceleration is negative. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Uh, Following table gives the displacement of a car at different instance of time. So here I have some information is given that time is 0, 1, 2, 3, 4 seconds. At different time, what is the displacement? We need to first plot this information on the displacement time graph and then find average velocity of the car. And also we need to find displacement of the car at 2.5 seconds and 4.5 seconds. Okay, so let's try to do it together. Okay, so here on a graph paper, this is my displacement axis and this is my time axis. Okay, I can do the marking like, okay, there's enough space, so I'll say 0 second, 1 second, 2 second, 3 seconds, 4 seconds. This side we need the data still like 20 at least. So what I'll do, I'll take gaps of like this is 5, 10, 15, and 20. Okay, so that is displacement on the y-axis. This is time. Also write displacement is given in meters so that we don't get confused, and time is given in seconds. Okay, now let's try to plot this information. It says when the time is 0, displacement is 0. So this point here. So they have just discretely told for few intervals. Then we will roughly try to predict the graph. So at 0 it is 0. At 1 it is 5. At 2 it is 10. At 3 it is 15. Okay, so let's now join these points. Okay, so when time is 1 second, displacement is 5 meter. When time is 2 second, displacement is another 10 meter, and so on. So here okay, this is how the graph look like. First part of the question says find average velocity. So average velocity we studied is total displacement by total time. Okay, for this car, what is total displacement in 4 seconds? Can I say total displacement?
20.
20 meters. Okay, good. And in how much time? 4 seconds. Okay, so therefore average velocity is 5 meter per second. Simple. Okay, next they are asking us to find the displacement of the car at 2.5 second and 4.5 second. So what is displacement at 2.5 second? 2.5 second I think lies here. Okay, so y-axis is where the displacement is. So I think we can draw a line like this at 2.5, and where it meets the graph I can draw a vertical line like this, and wherever it meets the y-axis. Between 10 and 15, what's lies right between 10 and 15?
12.5.
12.5. Yeah, that's correct. So at 2.5 second displacement is 12.5 meters second. At 4.5 second, so at 4.5 second you can draw a vertical line same way. and try to connect this with this y-axis. So it is 20, and then here it is 25. So right between 20 and 25 we have
22.5.
point. Okay, so I hope this is fine. You're getting a little hang of this. Simple. Can you quickly tell me this one if you're confident? Okay, this is easy. This I think you can just tell me orally. Here we have a displacement time graph. What is velocity of the body as per how it moves in 0 to 5 second, 5 to 7 seconds, and 7 to 9 seconds is given by formula displacement over time. So in 0 to 5 second, if you observe the graph carefully, in 0 to 5 second it travels 3 meters. So velocity is 3 upon time 5 seconds, which is 0.6 meters per second. Clear? I hope that's fine.
Yes, sir.
Okay, quickly. 5 to 7 seconds. What is the displacement in 5 to seconds? 7 seconds.
3.
It's not 3. 5 to 7. What is the change in displacement?
So it's not moving, I guess.
See, at the beginning of 5 second, displacement is 3. And at the end of 7 second also displacement is 3. So what is change in displacement? From 3 it changes to 3. So what's the change? By how much it changed? Did it change at all?
No.
So when there is
No.
no change, we say change is 0.
Yeah, 0.
Correct. So the correct answer here is 0. 0 divided by 2 seconds. 0 divided by anything is 0. Okay, so this velocity is 0 meter per second, and that's what we learned. When the line is horizontal, the displacement does not change, means velocity is 0. Clear? It is at rest. Okay, last part. Velocity from 7 to 9 seconds. So 7 to 9, the displacement is how much? It goes from 3 to 7, right? So that is how many units? Like at 3 to 7. So what's the displacement?
4.
4
4.
meters. 4 meters,
Okay, I got it.
and in how many seconds? 7 to 9. 2 seconds.
2 seconds.
So this is 2 meter per second. Clear?
Yes, sir.